Okay, so another crypto challenge. 2 of them, I think. I think I'm going to do both of them. So for a first hex shift cipher, I thought this one was harder than CEEBC. I thought CEBC was the easiest, but this is like reversed totally from my opinions of difficulty. So I'll just download this. Get that. Okay, so we've got the output of the program here, which is the ciphertext. And so we know the plain text looks something like the secret message is, and then plus the secret message in hex. And so if we actually look at how this is encrypted, well, so this encryption function uses the add function, so I'll look at that first. So we've got 2 numbers and we want to add them. So result 0, we add on to it the first number ended with 1, so it's last bit of the first number, last bit of the second number, add those together, so that's the same as XORing them because we're mod 2. And then we move that over by whatever bit we're on, by whatever I we're on, because we're looping through that. So first of all, first time we don't shift it at all, because that's going to be a 0. Next time we shift it 1, next time we shift it 2. And then we set the first number, we shift it over to the right, so we get rid of that first bit. So this just means we're getting first bits, XORing them, adding that to the result. Then we're XORing the second bits, shifting that over a bit, and putting that on the result, and so on. So overall, we're just XORing the 2 numbers, but only the last 4 bits, first 4 bits, whatever you want to, however you want to call the order. It's the rightmost 4 bits, and we're XORing those. And that's going to be our result. So anyway, encryption. So we've got key, which is the hex alphabet shuffled, S, which starts out as 7, and ciphertext. So we go through each character of the message, and the cipher character is going to be wherever the message character is in this shuffled alphabet, XORed with S, because this is add, which is S, and then that character in the key. So this would be really simple if the key were just the alphabet, but we actually don't know how it's shuffled around. And then we add that to the ciphertext, and then the new S value, which is what we're XORing with the index of the message character, is this new index of the message character. So basically, we know what it starts with, so I'm just going to convert this to hex to compare it. So we know that the index of 5 XORed with 7 gives the index of 8. We know that the index of 4 XORed with the index of 5 gives the index of 5. So immediately we know the index of 4 is 0, because it XORed with 5 gives 5. 6 XORed with 4 gives 6. 8 XORed with 6 gives 7. And so we've just got a system of XOR equations. And we want to solve for what this key is. So the first time I tried solving this, I tried using a simple Gaussian elimination. I might have had a problem in my code or something. It didn't work. It gave me that multiple values had to have the same index. I must have made some mistake in my code or something. I don't totally know. I found a different way. So I guess it's fine. The way I found to do it is just sort of by hand. So if I know... So first of all, I'm going to call 5's index a free variable. We can change that to whatever we want, so we'll brute force through that. And then we know, and I'll actually call this I5 to be the index of 5. And then we know I8 is going to be equal to 7 XORed with I5. 4 is 0. I4 is 0. I6 I'll call free. I8 is equal to I6 XORed with I7. Let's see. Is 7 anywhere else in there? No, so I'll call I7 free as well. And then I'll just keep going this way. And once I got a little bit through, instead of just going through nibble by nibble, I just went through and looked what am I missing right now and just filled those in. But anyway, IB is equal to I5 XORed with I6. Oh, I messed this one up. So this should have been I7 is equal to I6 XORed with I8. And we know I8 is I5 XORed with 7. The number 7, not the index of 7. Okay. And then IC is equal to I5 XORed with I2, and I'll call I2 is free. And then I0, I'm going to reorder this one a bit, is equal to I2 XORed with I5 XORed with 7, which is I8. And so I2 with 0 is 8, so that means 8 with 2 is 0, and so I just reordered it to get I0, because that's the new bit of information. And then I'll do the same thing here. I3 is I2 XORed with I6. I'm going to look for a 1 in here. Yeah, I'm going to look for a 1. No, not yet, because this 7 isn't actually free. So let me see. So 0, 7, 3 is net. Where am I? Okay. So what did I just do? I3 is 2 with 6. Okay, yeah, so that's this right here. So next B is 6 with 5. And then I3 is 6 with 2. We already have that. We already have B. E is I5 with I7. I7 is I6 with I5, those cancel with 7. And then we already have 8, 2, and 0, right? Yes. Okay. And then next, at this point I just sort of started looking for stuff. So we still need a 1, so where's a 1 in here? Well, we can see 1 is IE with I6. So I1 is equal to IE XORed with I6. And then we have 1, 2, 3, 4, 5, 6, 7, 8, no 9. Do we have an A? No, we don't. So A, B, we have C, we have D, we don't have E, we have F, F we don't have. Okay, so let me see. I'm gonna get a if we look for a 9, it involves a D, which we don't have yet. So I'm gonna go on to A, and here I5 XORed with I3 is A. So IA is equal to I5 XORed with I3, which is I2 with I6. A, and then we have C, and then we are missing D, F, and 9. So I'm going to look for an F. Well, that's simple. That's just 0 with D. So IF is equal to I0 with ID. ID. Wait. Is that what it was? I6. And I0 is I2, I5, I7. Or just 7, not I7. And so there's IF, and the 9 and D we don't have yet. So I'm just going to say D is free. And I9 is equal to I6 XORed with ID. So now we've got 4 free, and they have to all be different, and there's 16 possible values they can take on. And so that means all we have left are 43,000 possible options, and that's much smaller than what we started with. So anyway, we can script this up. And so first thing I'm going to do is import itertools, because that's just going to make this much easier. And then I'm going to try grabbing all of the possible keys. So I'm going to put those in a list, and then I'm going to get itertools dot permutations of, it's going to be the hex alphabet, and I think itertools is going to want that as a list, so I'm just going to make it a list like that. I think I could have just said list like that. and 4 of them. And so that's going to be I don't know what to call it, I guess just like that. I'm going to make it a list. That might not be a good thing to do, but go through every value. I5 is equal to I of 0. I6 is equal to I of 1. This is arbitrary. I2 is equal to I2. And where's ID is equal to I of 3. And then I guess for the rest of it, so I'm going to make this 0 times 16, and then I'm also going to get the indices as a list, starting at 0. So 0 is I2, XORed with I5, XORed with 7. 1 is this. 2 is I2. 3 is this. 4 is 0. 5 is I5. 6 is I6. 7 is this. 8 is this. 9 is this. 10, or A, is this. B. This probably could all be automated, but I didn't do that. I don't think I'm gonna ever. This seems like it would be a somewhat annoying thing to automate. D is ID. E is that. And F is this. And I probably should make this alphabet a variable at the start, but I'm just going to put it there. Key. Key of indices of K is equal to J, right? Because 0 is going to be at whatever the indices are of the 0th thing, and so on. And then keys dot append quotes dot join key. And then right there, we should have all of the keys. And some of these are going to have duplicate values in the key, which we know isn't allowed. So I'm just going to say if length of key is 16, then I'll append it to the length to all of the keys. And then I'll print out how many keys we have left to work with. If I remember correctly, it's just a couple thousand, so it's quite small. Oh, that's not good. Yes. Okay. I'm just going to make these integers. Did I not? Oh. Yeah. Let's see. Where am I referencing IE? 1? Okay. So I'm going to replace that with I6 XORed with 7, and that's going to cancel, so 1 is just 7. Just like that. That was an oopsie. Now it should work. No. Yeah, so it's just 2,500 about possible keys. And so now I'm going to write a decrypt function, which they don't provide for us, but it's not too hard to write. So first of all, s is equal to 7 for I in C. Plus equals, well, it's going to be I, and I'll say key.index I, XORed with S, and key of that. And then S is equal to this in here, and then return out. Okay, so for I in keys, print out print decrypt C, and I need to define that key. I called this I dot decode hex. It's this whole thing. That didn't copy. That whole thing. Run that. I not copy the whole thing? So it's... Oh. Yep. Okay. No, didn't copy that whole thing. I'm just going to cat that. And copy it there. Run that. Clear. And decode that with hex. Run that. And we get a flag. Did you use guessing or linear algebra? And that's it. That took a while. I'm not going to do the next challenge in this video.